Hey guys, welcome back to another video. So for number 9, I've gone ahead and done every single problem like really quickly with a complete breakthrough, and I'm just going to go ahead and show you what I did for every single step. So let's have a look. So it states that we got a sketch of part of the curve C with the given equation. Okay. Now it says that the point A lies on C, so here's point A and it's intersecting with the curve, and also B is also intersecting. And at point A, we know that the x-coordinate is 2, so this point has an x-coordinate of 2. Now, immediately before the question, if you know what the x-coordinate is, you can find the y-coordinate, given you have a y equation. So at point A, and because it's at the curve C, plug in the value of x equals 2 into the y equation. So when you do that, you're going to have 20 minus 4 times 2 minus 18 over 2. And doing so will result in y equals 3. So that's the trivial one, yeah? So that's the coordinates. Now, let's begin. Show that the equation of the normal 2c at A is given as follows. Now this is a straight up line equation, and when you have something like this, normals and tangents, always start with y equals mx plus c. So let's go ahead and see how I did it. So what I did here, okay, to get the gradient in every single case, you need to firstly figure out the gradient equation, and to do so we need to differentiate this curve equation. Yep. And before you differentiate, we need to firstly make sure it's all written in the standard x to the power format, like this, yeah? So 18 over x has to be rewritten as 18 times x to the negative 1, because we have to bring x back to the baseline. And differentiating this is easy. So let's have a look. Differentiating 20 is a constant, you get 0. Differentiating minus 4x, you get just minus 4 because x vanishes. And for 18, x to the negative 1, drop negative 1 in front, so it'll be minus 1 times minus 18 is plus 18. Subtract minus 1 by 1, you get minus 2. And you found it. You found pretty much an expression for the gradient. Now, when you want to find the gradient at a specific point like A, and it tells you that you have an x-coordinate of 2, plug in the x value 2, and then you have the gradient at point A. And now, when you do that, what happens? Plugging in ax equals 2, you get half. So this would actually be the gradient of the tangent. But because we want the normal, which is this line, by this line is the normal, you need to pretty much do the negative reciprocal. So flip 1 over 2 to 2 over 1 and put a minus sign. So it becomes minus 2. So we're done so far. So we found the m value so far. So now we have y equals minus 2x plus c. So far so good. Now how to get c? Well, we know the coordinates. We know what the coordinate is at point A. So all you naturally do is just plug in the 2, 3 into this equation. So when x is 2, y is 3, and then so for c. And in doing so, solving for c, you're going to get 7. And that's it, guys. You got y equals minus 2x plus 7. So we've pretty much proven this bit. So let's look at part B, yeah? Now, question 9 continued. So the normal to C at A meets C again at point B. So we discussed this already. So you can see they're intersecting. Use algebra to find the coordinates of B. Now, this is either straightforward or isn't. And by the way, I'll put the line equation here. When two things are intersecting, we solve them simultaneously. So we have to simultaneously find the x and y coordinates with the line and the curve. So we have to make them equate, okay? That's when you intersect. And doing so, intersecting these two equations will actually make us get to this stage. Because they both equal y, you can essentially equate them together and then solve for x. Now this is the easy bit, guys, yeah? You just pretty much use algebra now. So the first thing you want to do is move everything to the left side. So I did that. So I added 2x across and minus 7 to get 13 and negative 2x. Then I realized, you know what? We got x at the bottom on a fraction. Nobody likes fractions. So let's go ahead and multiply x across. So you're going to get 13x, 2x squared, and then just 18. And then just, you know, you could work like this, but what I would do, I like to make my quadratics positive, yeah? So I move everything to the right side. So I get a positive 2x squared, negative 13x, and plus 18. And now, depending what method you want to use, I use the quadratic formula because it's quick and easy, no risk. And you get to use a calculator. So using quadratic formula where a is 2, b is minus 13, and c is 18, plugging in the necessary values, you should get an x value of 2, which represents the coordinate a, because of course it's intersecting, and another x value of 9 over 2, which must represent b, because 9 over 2 is what? 4.5, which is of course more to the right. So using 9 over 2, plug this x coordinate to any single equation. So you could have plugged it here or plugged on the line. I used a line and I got -2. And just to verify, I used a curve next and also got -2. And that's it, guys. That's literally it. I mean, I hope this video helped. And if you guys got any more questions, you know, let me know. But otherwise, thanks for watching. And of course, please subscribe and like and share these videos with your friends and buddies. But otherwise, see you guys next time, inshallah. And take care. Bye.